Hello, my name is Craig Cornwall. This is my Tinkercad simulation for FSE 100. My team name is Everyday We Panic, and the name of my robot is Get Off My Lawn. It is an autonomous robot designed to patrol around a garden bed, detect pests, and scare them away. In this video, I'll explain how the code controls the robot's movement, sensors, and deterrent system. The robot contains 2 ultrasonic distance sensors, a PIR motion sensor, a speaker, a servo, an LED ring, and 4 DC motors to control the wheels. The first ultrasonic sensor is fixed on the left side of the robot and always faces towards the garden bed. This sensor acts as the robot's guide for perimeter navigation. It constantly measures the distance between the robot and the garden bed so the robot can follow the perimeter while staying at a consistent distance. There is also a fixed speaker mounted to the front of the robot, which is used during the pest deterrent sequence to play warning tones and scare pests away. On top of the robot, there is the second ultrasonic distance sensor, PIR motion sensor, and LED ring. These are all mounted on top of a servo motor. The top ultrasonic sensor and PIR motion sensor work together to detect pests. The servo starts at 90 degrees and scans 180 degrees, allowing the robot to monitor almost everything around it except the left side facing the garden bed. The LED ring is part of the deterrent system. When a pest is detected, the LED ring flashes red. When the robot first turns on, the code begins by setting up all of the robot's components. It tells the Arduino which pins are connected to the sensors, motors, speaker, LED ring, and servo. Once setup is complete, the main loop begins running continuously. The robot first checks all of its sensors. It reads the PIR motion sensor to detect movement, the top ultrasonic sensor to check for objects ahead, and the side ultrasonic sensor to measure distance from the garden bed. The robot also prints these sensor readings to the serial monitor in real time. Here's an example of that. For the side ultrasonic distance sensor, it will also print a statement too close when under 8 inches, good distance when between 8 and 16 inches, or too far when over 16 inches. This helps confirm that the robot is maintaining the correct distance from the perimeter. And here's an example of that. So too close, you'll see that the left wheels will go forward and the right wheels will go backward, effectively turning the robot right. When it goes over 16 inches, the wheels will do the opposite of that and print too far. And when it's in between 8 and 16 inches, you'll see good distance and the robot will continue forward. Here's an example of that in the code. Follow edge. For the pest deterrent sequence, if the top ultrasonic sensor detects an object that is closer than 10 inches, the robot immediately stops. If the PIR sensor also detects motion, the robot identifies it as a possible pest and activates the deterrent system. If there is no object directly in front of the robot, it checks whether anything is within the pest detection range, which is about 5 feet. If the ultrasonic sensor detects an object within that range, and the PIR sensor detects motion, the robot stops and starts the deterrent sequence. If no pest is detected, the robot returns to patrolling the garden bed. During the deterrent sequence, the robot stops moving, flashes the LED ring, and plays warning tones through the speaker. The goal is to scare the pest away without physically chasing or hitting it. And here is an example of that. So first I'll show you under 10 inches, and the robot will stop moving. As long as it's under 5 feet, then the pest deterrent sequence will activate if the PIR sensor detects motion, and here's an example of that. You also see it print pest detected when that sequence is activated. After the deterrent sequence ends, the lights turn off, the speaker stops, and the robot briefly pauses before returning to patrol mode and continuing around the garden bed. And here's a quick scroll through all of my code. Thank you very much.